Okay, a quick look at the hyperbolic functions. I'm just going to very quickly derive them for you. Now, recall that sine of theta, so a trigonometric function, was equal to e to the I theta minus e to the minus I theta all over 2i, and that cos of theta was identical to e to the I theta plus e to the minus I theta over 2. These were the exponential definitions of sine and cos that we looked at when we did complex exponents. Well, if I take these exactly as they are, but whenever I see an I just ignore it, then we have our definitions of what we call the hyperbolic functions. These are the definitions of the hyperbolic functions. This one is pronounced either shine or cinch. Doesn't matter, depending on whether you prefer the sound or whether you prefer the H being in its appropriate place. And shine of x, which is how I usually pronounce it, is defined as e to the x minus e to the minus x over 2. That is its definition. Okay. So these are new functions, shine, and this one here, cosh, but they are defined in terms of functions that you've already met, e. Cosh of x is defined in a very similar way, except instead of subtracting the negative exponent, we add it. Okay. And these two are defined as hyperbolic sine and hyperbolic cosine. Hyperbolic sine and hyperbolic cosine. Okay, that's their definition. Just in the same way as tan is sine over cos, we have this function here, which is either pronounced than or tanch, so it's than or tanch, and that is defined as shine over cosh, so that's going to be e to the x minus e to the minus x over e to the x plus e to the minus x, and the 2's will cancel. Okay, that is the exponential definition of than or tanch. It's referred to as hyperbolic tangent function. Okay. There are the reciprocals. You have sech, cosech, and coth, but I won't go into those. It's just the reciprocals of these three. And we'll have a look at the graphs. We'll have a look at some identities of them, and we'll look at solving equations involving them in future videos. Thank you.